Welcome. Today we're demonstrating the overload relay that we find on our Gould motor starter. And I'd like to point out a few of the features that we have here, show you all the different parts of it, and then we are going to show a quick demonstration of how it operates. First thing I'd like to show you is the power side. This is the side that would have the 480 or the 240 or whatever voltage you have running through the motor. And remember that full motor current runs through this type of overload relay. And this part here, this is what's connected to the back of the contactor, the downstream side of the contactor. And from there, it goes into the overload heater, goes down the middle, comes out, and there's a piece of mica insulation that has this nichrome wire wrapped around it. And the outlet tab is separated again by another piece of mica to keep the inlet side and the outlet side separated. And then we go off. This would be the connection to your motor. So that's what comprises the power circuit side of it. Now on the control side, we have whatever your control voltage is, your 120 or your 24 volt control, comes in the bottom here, comes up, goes through this copper plate here, through the contact. The contact is currently closed, and comes back and goes out the other side. Now I'll show you the contact opening back and forth. You can see the spring causes it to act in a very fast opening and fast closing manner. And the other key elements here are the bimetallic strip. And the bimetallic strip is two dissimilar metals bonded together. These two metals are chosen specifically because they have a difference in coefficient of thermal expansion. The metal on this side has a higher coefficient of thermal expansion, meaning it grows faster than the metal on this side when is exposed to heat. And what this will cause is to have this bimetallic strip will bend, and it's going to bend in this direction, and we'll see that once we put the current to it. So again, to show you that heater, here we can see the heater. I have another spare here. Here we have this is the inlet side here, and the wire is attached to the bottom of that. Then we have the mica insulation. We have the nichrome wire that's wrapped around it. This is a precision resistor that's selected exactly for this T19 heater that we have. And we see the outlet tab here, it's bonded there. And we have a mica insulation in between the two parts, protecting it from short-circuiting and creating our circuit there. So all the electricity comes in, goes to the bottom. The wire's connected down here. This portion is insulated. We have the wraps of the nichrome wire, which will generate the heat, which will start affecting the bimetallic strip that's right next to it. And when the bimetallic bends, there's this link bar here. The link bar has two pieces that are not easy to see, but there's those two parts there, and one will get pulled on by the bimetallic strip. The other will pull on the spring, opening the contact. So what I'd like to do now is turn on our current source. We have our current source hooked up here and here, and we have the control circuitry hooked up here and here. We have a special type of current source that's used for breaker testing, and these two leads connect to the contact leads on our tester, and when the tester detects that the circuit has opened, it'll stop the timer and shut down the test. So without further ado, here we go. We've just started energizing. Current's flowing through it, and we're heating up, and quite shortly you'll see, yeah, there we go, we're starting to see the bimetallic is starting to deflect, and you'll see it start to pull over. You can see it bending more and more, and in just a few seconds we should see it pull the bar far enough that it pulls the spring, opening our contact. Got a pretty good bend going there. There you go. And that concludes our test there. The other feature that we have on this unit, we have this trim tab on the back, which allows us a plus or minus 15% adjustment. And we have a reset button here. Now the reset button won't work right now because the bimetallic is still bent. And that concludes our show.